All right, so this is AKS 56. So this is talking about complex numbers. Two main things that I need you to know is that I squared is -1 and I is the square root of -1. Okay, so this was talking about imaginary numbers. Okay, so this was when there's a negative underneath the radical. We don't like that because it doesn't produce an actually real number. So on this one, you're multiplying complex numbers. Okay, complex means you have a real part and an imaginary part. Okay, you're not just having the imaginary part. So this asks, what's the simplified form of the expression written in a plus bi form? Remember, that's your standard form. You want to make sure that you write it out that way. So I'm going to do the FOIL method. Okay, so I'm going to distribute 7 times 3 is going to give me 21. 7 times 16 is going to give me 112i. And 13 times 16 is going to give me 208i squared. And the reason why I put I squared is because we've got one I chilling over here, one I chilling over here. Okay? So then what we're going to do is we're going to combine our like terms. Our like terms are ones that look identical. They're kind of like twins, right? So you've got this 112i and this 39i. Okay? So you're going to combine that, and when you add 112i, and then we also know that we've got this I squared chilling out here, right? But we've already said that I squared is -1. So we're going to plug in a -1 here, and that's going to make this minus 208. So now we have two real parts, and we can combine those real parts together, right? So we're going to take 21 and subtract 208 from it. And that's going to give us -187 plus 151i. If you leave off the I part, it's wrong. Okay, so please make sure that you include that. So on number 2, we've got -5 minus 7i squared. So really this is like saying -5 minus 7i times -5 minus 7i. Plus -8 minus 4i. And this asks for the imaginary coefficient. So we're only looking for one specific number, right? We don't actually look for the final answer. But we still have to multiply this out. So we're going to do -5 times -5, which is 25. -5 times -7i, which is positive 35i. -7i times -5 is going to give me 35i. It's going to give me positive 49i squared. And then we've got -8 minus 4i. Okay, I just took out the parentheses because I don't really need them. Okay, so now what I'm going to do is I'm going to highlight my real and imaginary terms. So I've got 35i, 35i, and -4i. Okay, so in my calculator, I'm going to type 35 plus 35 minus 4, and that's going to give me 66i. Okay, and then we also have 25 minus 8. 25 minus 8, which that's going to give me 17. And we've got this we've got this I squared, which is going to be -1. So we're going to subtract 49. So we've got 17 minus 49, which is going to give me -32 plus 66i. Now, what did our question actually ask for? Remember, it asked for what is the imaginary coefficient. So we just got to list out this guy. So we're just going to say that the answer is 66. So it just wants the coefficient. So that's just the number that's up front. Okay. All right, so AKS 57 is asking about the conjugate. Remember, the conjugate is the opposite sign of the imaginary term. So if we have a plus bi, the conjugate of that would be a minus bi, right? So then this asks us, what is the complex conjugate of -3i plus 13? Well, first we want to put that in standard form. So that's going to be 13 minus 3i. So now we're going to make that have the conjugate, right? So we're going to change the sign of the imaginary And that means that it's going to be 13 plus 3i. No, we don't change the sign of the real, just the imaginary term. So the conjugate is when you change the sign of the imaginary term. Yeah. So if it's negative 3i, now it's going to be positive 3i. Okay? Now, this is where a lot of people mess up. And this is actually where you use the conjugate. So when you're dividing, we don't like having an I in the denominator. That's like having a square root in the denominator. Not a big fan of that. Okay? So we're going to multiply by the conjugate in the top and in the bottom. And the reason why we do it in the top and the bottom is because the I will disappear in the bottom, but you can't just do something to the bottom and not do it to the top, right? Okay, so now we're going to actually multiply this out. Okay, so 2 times 3 is going to give me 6. 2 times negative 2i is negative 4i. Negative 15 times 15i times 3 is going to give me negative 45i. And negative 15i times negative 2i is going to give me positive 30i squared. A lot of people make the mistake when they multiply I times I. Please, 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 please make sure that you pay attention to that I squared because it does change your answer. On the bottom, we're going to get 3 times 3, which is going to give me 9. 3 times negative 2i, which is negative 6i. 2i times 3 is going to give me positive 6i. And 2i times negative 2i is negative 4i squared. Okay. We're then going to identify our like terms. So in the top, we've got this negative 4i and negative 45i. And in the bottom, we've got negative 6i and positive 6i. Okay, so in the top, if we combine our like terms, we're going to have 6 minus 49i plus 30. And we've got that I squared chilling there, right? So we're going to put in a negative 1 instead of keeping that I squared. On the bottom, we're going to combine our like terms, and we're going to get these cancel out, and we've got 9 minus 4. Remember, you've got an I squared chilling out here, times negative 1. Is this in the simplest form? No. We've got to simplify a little bit more. So we're actually going to multiply that 30 times negative 1, and that's going to give us negative 30. So we've got 6 minus 30, which is going to give us negative 24 minus 49i. I'm sorry, I'll highlight it for my visual people. This and this come together. And then we've got 9 plus 4. And the reason why I have plus 4 is because negative times negative gives us a positive. So 9 plus 4 is going to give me 13. And you always want to check and make sure that you can't divide everything by a common factor. So down here, we can't divide everything by 13. We can't divide everything by 24. There's no factor that they all share. So we are finished. Okay? If you ever end up having an I in the denominator, you have done something wrong. Okay? Okay, so AKS 45. So this is writing the composition of a function and then interpreting what it is or what the composition actually is. So it says, the weekly cost of producing the new iPhone 11 in a manufacturing process is written as the function c of x. So first of all, before we go any further, we've got this thing called c of x, right? The cost is given by $850 base salary for workers and $60 per iPhone created. So again, we're just going to stop. We know that c of x is going to be this nonsense. So we got 850 plus $60 per, and that per always tells us that we're going to probably multiply 60 times x. And the reason why I chose x is because x is inside these parentheses, right? That's going to be my variable. All right, so let's read the next sentence. Then it says there are 5 iPhones that are created per hour, t, modeled by the function x of t. All right, so let's write that out. So we've got x of t, which is a function, right? And we've got 5 iPhones that are created per hour. Okay, so 5 times t, because we get 5 iPhones per hour. Now it says create the function c of x and x of t. Wow, we've already done that. And then what is the composition of c of x of t? Okay, so we've got the functions right now, but now we've got to actually do the c of x of t. This is also known as c of x of t. These are the same things. Okay, don't get tripped up by the notation. Okay, so the first thing that we're going to do is we're going to write out what our c is, right? And our c is 850 plus 60x. And then we're going to take x of t, which is 5t, and plug it in for x. Okay, so we're going to take this and plug it in for that x. So we've got 850 plus 60 times 5t. And then you always want to simplify because nobody wants to look at an equation and be like, what's going on? Right? So we're going to have 60 times 5, which is going to give us 300t plus 850. And that is what c of x of t is. Okay? All right, so it says, according to the U.S. Energy Information Administration, a barrel of crude oil produces approximately 20 gallons of gasoline. That's dope. EPA estimates that a Honda Accord averages 47 miles per gallon of gasoline. G of X stands for the number of gallons of gas produced by the barrels of crude oil. M of G stands for the number of miles on average that a Honda Accord can drive on G gallons of gasoline. What does M of G of X stand for in this situation? So let's take what M is, M of G is, right? So M of G is the number of miles Honda Accord can drive. Honda Accord can drive. Okay. So then we need to plug in G of X. And G is the number of gallons of gas produced by X barrels of crude. So what's happening is we're taking a Honda Accord, right? Bear with me on this because it does take a lot of thought. So we're taking a Honda Accord, right? And then we're saying, okay, how many miles are going to be in the number of gallons of gas of X barrels of crude? Okay, so here it is again. They average 47 miles per gallon of gasoline, right? So we're trying to figure out how many barrels of the oil is it going to take to run a Honda Accord. Okay? So we're trying to figure out how many barrels it's going to take in order to let the Honda actually run. Yeah? This one's a little tricky.